Welcome to episode 11 in the BotPod of our Tech Talk series with Lawrence Harvey. Today is a really fun episode. I'm joined by Jonathan Laporte, part of the Fugro group, as the head of software and product director. Spent a really cool career working at the intersection of robotics, autonomy, and maritime systems, with the work focusing on building robotic systems that operate in some of what we'd call the most unforgiving environments on the planet, I think, and that being the ocean. And I think that's what makes this, for me anyway, a really interesting conversation from the offset, because I think maritime robotics and marine technology really feels like one of those domains where the simulation question that you have on land or road or solid ground robotics is very, very different. That, such fast-paced moving domains or not so stable, doesn't matter how good your simulation is, the reality and practice is usually so different. So this is going to be a really fun chat, I think, for me over all of our listeners as well. So Jonathan, thank you so much for joining me today. How are you?
Yeah, hi Danielle. Well, thank you for having me. I'm actually feeling great. Thank you.
Good. We love that. We love the positivity. Now, before we get into all the nitty-gritty bits, I'd love you to walk me through, but also our listeners through, like your background, how you ended up in the maritime technology space, and specifically like working across autonomy at sea.
Well, I ended up working in maritime autonomy quite randomly, if I must say. Um, I'm a mechanical engineer by trade, and what I like in life is basically to build design systems to fix a problem, ideally to end up making it very efficient. That's why I started to work in production management, making factories run, being efficient, which led me to managing the production of a shipyard. And one thing led to another. New projects came in, and I was asked, can you build an autonomous boat? Seems like it's an interesting technology. It was 2016, and it was fairly new. We still had a few early players in the market, but not that many. And I was really interested because I looked at autonomous cars and how they can change the world, change the infrastructure and change how we do motion, anyway, as humans. So I said yes. Um, Spent a bit of time to do my first business study, look into which solution could help our company be more efficient. I was working for iXblue at the time. And that's how we ended up with the concept of USV, which later became known as the TREX, the RIX. So that USV is basically a force multiplier, which allows us to do one thing and do it very well, which allowed the market to be scalable because it was very linear at the time. I've built 5 Drixes the first year, so it was a very high-paced innovation environment. We did sea trials almost daily. We improved the systems and the production. I was suffering through all the stages of a prototype and all the late hours and all the physical pain which comes with that. But that was really exciting. I was being the operator and the designer at the same time, so that was a great learning opportunity. Quickly, we got some success. People started to notice us, and one thing led to another. That's how I ended up working for Fugro, where I started 5 years ago. It's a different world, much larger scale, bigger boats, bigger robots, which we call ROVs for remotely operated vehicles, which happen to be subsea vehicles, and also a different way of approaching the problems. I went from a very high-paced, disruptive environment where maybe we didn't have that much of an offshore culture as we could have for the big players, but we tried stuff and we broke stuff and we made stuff happen. While I came in a company which is 60 years strong, lots of experience, and has seen it all. They have been through the problems. So they ended up with a radically different approach and solution to a somewhat similar problem. So I made lots of changes and steps in Fugro in the past years, but long story short, now I am leading the software division in charge of our navigation software for the USVs, so uncrewed surface vessels, and ROVs. which basically allows us to develop a software for our fleet of robots to make it scalable, to improve fast and do some CI/CD based on the needs of our customers.
It's really interesting. You almost mentioned that you also like kind of fell into this robotics or like ROV, USV kind of world. I feel like now, if you have people trying to enter this type of industry, you wouldn't really see someone falling into it by accident per se. It's they probably spent the past decade of their education and research experience specifically looking into these technologies or this space. So it's lovely to hear, but it's a really interesting concept that you fell into it in a separate realm where I think that'd be much rarer nowadays with the kind of talent pools and direction that teams are hiring in with their like bars or expectations at this kind of level.
I think I got lucky to be at the right place at the right time. I had the tools to build something new with the shipyard, and we had the ambition to try something disruptive. So that was really nice. The fact that we were not the first movers, but we were fairly early second, that allowed us to avoid some mistakes and yet do something new. I would say now that it's almost 10 years later, you have a different approach, a bit more structured, probably. Um, so you have pros and cons. The thing is that there was a lot to discover, but now you can also go deeper with more expertise. You can also come and accelerate some of the most difficult parts of the developments, which relates to how to properly design the right hardware and how to properly develop software with the nice algorithms and all the AI-powered things that we see.
Oh, definitely. And I think that leads us really nice when we talk about like, lab versus real world environments, especially if we talk about like the simulation piece. So I guess we go back to that simulation and start really like obviously here, where there's like a point where lab autonomy kind of stops being as meaningful or maybe valid when you're deploying offshore. So like what is it that you see as that first kind of change or that kind of ticking point to break that transition?
Well, actually, algorithms for autonomous vessels have been out there for many, many years. And you can see videos of toy boats playing in a pool in labs for a long time already. I would say the difference is maybe a bit boring. It comes to industrialization. It comes to the fact that an algorithm will solve one problem or multiple subsets of a bigger problem, but it may not be able to cover the whole range of issues that you might find in the real world. Um, for instance, if you look at warehouse robots, they still live in a very constrained environment. You can paint tracks on the floor, you can have sensors everywhere, you can basically control where you operate. At sea, it becomes much harder to control the environment. So depending on where you want to operate, you might even need bigger assets because the waves just become bigger offshore because you have more strengths to play with. And that means that from the lab, which was experimenting on path planning algorithms, for instance, you end up having to use that same type of mentality and algorithms, but with something which is much more complex, which is made to be robust, sturdy, to survive the environments. Or you can make it very lean, but then you have to find fail-safes, you have to find ways to deal with when it inevitably breaks down. So the lab is really good to test complex scenarios when it comes to operating multiple robots or to try to test new things as a starter. But as soon as you go at sea, you have a cable which starts to vibrate and gets unplugged. You have fog on your camera. You have the engine which breaks down. You have too much water in your water cooling system. All of these things that you could simulate, but real life just catches up really quickly.
No, I definitely would agree with that. And I think from some of our previous conversations, we've kind of mentioned this like stress test that is almost, the
Mm.
full environment of the ocean and the sea, which is, one of the largest technical physical environments we have when you're going air, land, water, right? Um, I think it's, a really interesting frame when they say this is like an ultimate stress test. Would you like compare this closest to like working with like space and satellites, or would you frame this like completely differently in terms of the type of unstructured environment it is?
Well, I think that each environment has their own sets of challenges, right? So I cannot speak too much for space, but what I would say a common point is that we don't ship that many units in that big unknown. Um, in the ocean is vast. As big as they may be, the robots are still fairly small compared to what we are talking about. And the difficulty is that you are at the junction of air and water, which actually brings two different types of liquids you have to work with. So you may have currents, you may have waves for the vessels. Subsea, you also have other types of challenges because light doesn't travel well underwater, especially if you have all sorts of noise and turbidity. So the things you could do in space, which basically gives you an open line of sight towards Earth or on land where you have infrastructures and you have a lot of antennas and things to tell you where you are much more difficult at sea. Underwater, you do not have GPS. You may struggle to find any source of information as to where you are. At sea, if your platform is low on the horizon, you may not even be able to get a radio connection because of all the fog. If you are far away from shore, you can forget about the 5G and that sort of thing. So uh, that environment has unique constraints which make it hard to just go on outside and play with and learn.
Yeah, I appreciate that really will change how you think about like testing or like testing prototypes and validating things. And it's really interesting that you mentioned, drifts and currents and water pressure and all of these things because it's so different from, your standard AGV, AMR, robot arm in a warehouse style environment. Um, so I think that, once you've done this and you're like stress testing the system, what's that kind of what like kind of go what gives first? Is it more the communication side? Is it the perception? Is it how you think about navigation with there being drifts or currents? Is it the type of hardware you need to physically put in this environment because it is water, not air?
It really depends on the use case you are trying to solve, right? And I much rather try to consider something simpler than trying to come and have a solution which solves all our problems. You can do a lot with software, right? Well, you have infinite solutions to fix that, but your software has to interface with the real
With
world.
hardware.
Yeah, and as soon as you try to interface with the real world, you find out that you cannot carry anything and everything. On the vessels, you may be able to bring all sorts of sensors. You have radars, all types of radars, cameras, infrared cameras, you have antennas, communication. But the more you carry, the more you have to think about fail-safe procedures, how dependent you are on each individual sensor and actuator if you have tools which do work. And if you want to be having some sorts of feature redundancy and not be hardware redundancy dependent, then that's just more work, right? You have to develop more and it costs you more money because basically you multiply the interfaces, you multiply the edge cases of the things which may break. So it's really hard to give a generic answer to that question, but really we need to go back to the roots of what are we trying to solve. We may not want to have an all-knowing vessel which can go from port directly to our clients and do everything. And should we not have programmed anything, then they just find a way. Maybe you may want to do something simpler, supervise, control the vessel when it is easy and manageable, and just have for the vessels or the submarines a subset of behavior which are predictable. That also allows you to, well, easily know what may go wrong if things fail.
Okay, that's really interesting. I appreciate maybe I asked you a bit of a too much of a generic question there, because of course it will depend on client requirements or the specific needs of said product or like service that is kind of going out within that application that, maybe navigation for one customer is more important, but the other is the communication layer or like the interfaces. So I definitely appreciate it's a tough question to answer when there isn't really a single response. But again, you kind of mentioned this like this software heavy layer as well. Like, is there something from your experience or that you've seen that people almost underestimate when they come from a land robot world or a software heavy background than someone that hasn't seen this type of high level unstructured environment?
Yeah, I think if we try to compare land and sea, as far as I know, land, um, you have pros and cons. You have things which play in your favor and things which don't. Let's start with the tough one. Um, at sea, the road moves. So even if you plan a path and you have a huge wave coming your way or lots of current underwater, you will be impacted by that. You will move, you will drift, and you have to find the right way to go back on track. And if you try to be holding a position in space, you have to know that you will have disturbances, that sort of thing do not help you. I also mentioned the fact that you may not have communications. If you operate in the northern part of the planet, you struggle to find a satellite to communicate with. So you are basically a robot on your own in a very, very cold environment. Subsea, that's the same. I said you do not have GPS signals, so you have to help your robot find a way to know where it is at some point. We have all sorts of tools. We have motion units, which help you see where you move, but they also drift with time. So you have to come back in the surface and just get your GPS position. That's what submarines do. Or you have to find a way to have beacons or to have a boat which has a way to communicate with you. And that makes it more and more complex, as I say, the interactions. The thing which is, I would say, playing in our favor compared to land-based robots, if we take autonomous cars, they have to deal with 1,000 inputs a second. There's a lot going on. So yes, they have 5G and they can rely on the infrastructure and very visible signs most of the time, like red lines, white lines on the red lights, white lines on the street. So you need a much faster way to get access to decision making. At sea, well, if you are in an open sea, you are probably capable of detecting that container ship, which is 500 meters away from you, and you have the time to react. And also the boats and the systems can have any size, shape, and form that you want, which also allows you to design for purpose, for purpose, for the mission. So if you have a bigger asset, you can have more computing power, more sensors. So that also gives you more space to play with and is less stringent on the reactivity of the asset itself. So some things make it more complex, some things make it more easy. Um, and yeah, so you just have to understand what constraints and what variables you are playing with.
It's actually really interesting. Like, I've thought about it in the sense before because we've spoken about,
Mm.
imagine the road moving, and that's, one thing if you're comparing road to ocean, but yeah, it's like the human interaction, the level of like not necessarily traffic, but like data that it needs to account for in its surroundings. I think that's a really interesting way to think about the difference between autonomy at sea and compared to your standard ground robot, whether it's a AGB, a humanoid, an AMR, whatever it is. I think that's, yeah, really interesting to think about uncertainty because the fact where these ground or land robots have to make a higher level of decisions in a quicker time frame, it actually almost makes me understand how the challenges do really differ in regards to, yours having this communication layer, but not having the um physical traffic or like in-person issues of like who you're going to bump into, what you need to be aware of, how
Mm.
quick or how like what level of depth do you need your lidars to be able to present for X level of distance for stoppage time or whatever. That's actually really interesting to think about it in a
There's,
different way.
there is also one thing which changes how you prioritize development. Let's say your ultimate goal is to have tools, robots, which do one thing automatically or autonomously and allow for the mission to be executed even with a bit of uncertainty. So a car, you send a text message, it comes pick you up from somewhere, anywhere, drops you somewhere else, and you can be hands off the whole trip. That's cool. For vessels, they go from A to B, they do something, come back. So both have the same objective of being able to do something with as little human intervention as possible. However, by design, um, we build our robots to be uncrewed. That allows us to have freedom in designing the hardware, that allows us to be safer in rough environments. But cars, planes, they have a human operator moving the thing. And that's really interesting because if you look at how do you integrate autonomy, you might want to prioritize one thing over the other. If a car doesn't have a connection with a server for autonomy, you can still push on the brakes, start to take the wheel. If the uncrewed robots are far away from shore and they do not have communication, then something needs to happen. And that's a thing that you need to preemptively program, and you need to try to figure these edge cases, which may sometimes not even be edge cases, may be embedded in the way you design it. So that's quite interesting because you will prioritize the development of, I would say, lane assist differently as you would for an automatic braking system. You just want to have all the same features, the same philosophy at the end, but you don't roll them out in the same order, and you don't take the operators along with you in the same way.
And I love the fact you kind of brought up connectivity because it's something I was really keen to touch on next, where, you talk about 5G enabled environments and these satellites, when we talk about warehouses, you have enough issues getting connection from one end of a warehouse to another. So when we're speaking about this massive environment that's like, the ocean, and you can't always connect to satellites, like you said, like in the, the North Sea or the north of the Northern Hemisphere. Like, so when you have these issues, like how do robots like make decisions, or like how do these like USVs make decisions where like either fully disconnected or like partially blind, I guess could be the right phrasing for it.
Well, again, the political answer is to say that you need to map your decisions based on the work it has to do. And I would say the pragmatic answer is you start simple. Um, you start by safety. So you do not want to have a rogue asset going somewhere if you don't have absolute certainty. You know what's going to happen. So that's where the perception of robustness of said algorithm or behavior also comes into play. So we have to find ways to benchmark the industry to know how we can rely on one thing or the other. But the basic answer is if you don't know what happens, you just stop the thing. You start by that, start by stopping the robot, start to find ways for the robots to not drift. So you have multiple ways to make them stay in place. You can have dynamic positioning, you can have them make round of turning the cycle forever. We can have them ping SOS messages with other types of communications, which just allow a tiny bit of data to go through. So you have many, many ways to start, but I always start by safety. So make sure that whatever you do is not going to harm the environment, potential users around, or any structure you might want to get close to. And then the next step is once you have that covered, you know nothing bad will happen. You can start to integrate a bit more. So how do you improve your perception? How do you make the robots know where they are, even if you cut half of the sensors? If you cut the GPS, but previously you were close to a structure and you know where it is in space, and you have some sorts of LiDAR or radar, well, you can do some SLAM, and suddenly you are not so impacted by that. You may have uh, different precisions, but that's fine. You still know you shouldn't go that direction or you will hit something. And that's how step by step you build capabilities inside the robots so that you ultimately end up with being able to keep doing the work, even if you don't have a direct supervision with that.
Okay, really interesting. Um, and I know before as well you touched on the kind of the edge computing piece. I'd love to like delve into that a little bit more, like in terms of how do you think about like edge computing versus like the remote control piece when we're talking in this type of environment.
Well, we have a big constraint, which is data, right? We cannot just send gigabytes of data. So yes, we have new types of connectivity with the new low orbit satellites, which are out there. So it's a bit more relaxed now. That being said, you don't always have what you need or what you want. So we start by figuring out what's needed for the human operators, assuming that the robots are just teleoperated, what do you want to do with them? So how do we work with them? And slowly you start to build in the robots themselves the capability to use that information that you already have anyways, for them to understand what's happening. You could go straight to full autonomy and no operators. That's a different philosophy, right? But I would say that if you go that route, then the threshold is much, much higher before you can operate in a harsh environment. So it's a different philosophy, but myself, I like to think that we already have a lot of things to play with. We already have vessels, we have skilled operators, we have lots of data, and we have the human oversight of how to behave at sea. So we should exploit that. We should use that. So in our remote operation centers where we actually operate our fleet, should it be a specific room or something else, we have some sorts of automation. We can have some sorts of automation. Let's say you operate a swarm, you want to have orchestration of the missions, you want the robots to do one thing then and then the other. You can very well do it from your station because the intelligence is controlled by the humans. And you just send orders to the robots. But since you have that constraint of data, you may want the robots to also have a way to understand where they are in the mission without human supervision. And that means that you have to find a way for them to also understand what they see, um, what they perceive. And that's how you go from basically streaming information in a raw format from cameras, radar, whatever offshore, to onshore, to having that information and for the robots to be able to start to slowly understand that what's not blue may be a boat or it may be a rock. And slowly you start to say, well, because I have seen something here and my radar tells me there is actually something far away, you can start to create a map of what's around you. Subsea would do the same with the sonars. So that's step two, is to be able to, from the robots, visualize, map what's there. And step three is to identify. So you know you have something somewhere. And if you are able to understand what it is, then you can start to react accordingly. And that's how slowly you build capacity in the robots so that they can react if you do not have communication or connectivity.
I think it's a really weird piece where you've got the eyes being in, one place, I'm sure, and then the
Mhm.
brain being somewhere completely different. It's like trying to get the two to work together. And if you lose one, it's how do we make up for the gaps or like make the assumptive workarounds to fix X if X can't connect to Y, right?
Yeah. And I'm fairly sure that they have that in space as well, and much, much bigger of a problem. There are delays in communication sometimes, even on Earth. In space, I think it's minutes, right, for the Mars rovers. And so you have to create your system in such a way that at some point in space or time, your robots will be in a different time zone as you are. They will be living in the past. What you get lives in the past. Information you get lives in the past. So, um, how do you keep being operative and efficient, knowing that maybe what you see is already 10 seconds ago? And for an operator, they are actually quite skilled at some point. They get used to that delay, which changes. Oh, I just said 10 seconds. That don't take my words for granted. It just depends. But what I'm trying to say is that at some point, some environments may force you to build in more intelligence in the robots just for the basic safety, just to make sure that when we give an order for an action, we are not actually endangering whatever happens far away.
I think that link's actually really nice when you think about the difference in like environments that can use GPS who have really strong kind of navigational systems compared to those where, you have a really bad storm. The sea technically could have been fine when you went to ship something out in the morning, but a storm's come over, it's affected the satellites, and now you've got no idea where the robot is, or like there's been like a delay or a lag in that kind of precisioning gap. And I think, the land robot scene can maybe almost take this type of environment for granted a little bit. I mean, in these types of environments that are like heavily degraded or like highly variable, whether, something's going to work or not, what kind of happens in these type of environments that you're like, of course, there's a safety aspect that you're really like trying to work through in this type of stack.
The answer will be boring. We try not to go in mission when we know a storm's coming.
But do you know what? It's like the simplest fix, but fair enough. Like it's don't need to be a roboticist to make that
Yeah.
assumption. But I'm thinking, well, what would you do? But then doesn't that affect projects, deliverables, like time frames? There's something super like time critical or urgent, and there's a storm coming over. Do you go, oh, well, time criticality doesn't matter here because there's a storm? Or like, yeah, what, how do you kind of mitigate that? Because weather, especially being a Brit in London, what the weather app tells me it's going to be and what it actually is are very different things. So how do you then work around something else that is so uh unstructured?
You have lots of things to look into for that question. I would say first, that's the offshore world's life, right? So the operators, whoever they are, they have been working in that environment for decades. They know the ocean is not something to be playing with. Um, that's why we have big boats. That's why we have huge structures because they are made to withstand some sorts of harsher environment than what you would be looking at if you are on a plastic canoe in the Mediterranean, right? So the thing is, first, industry-wide, it's something which is known, something which is mitigated, and we work around that. Not really my field of expertise now. Where I'm looking at, I'm thinking about the robots as having sensors, and they also have actuators. Some of the robots may have to dock into one another. And that's a heavily complex operation to be done remotely. So I'm saying that since you have two things moving in 360 degrees in two different mediums, water and air, that's harsh enough, right? Can you start to have algorithms, motion prediction to know what's going to happen? That's actually a very hard question to answer.
Mm.
So you have the algorithmic side, which may help you say, because I'm seeing clouds, because I'm seeing the motion and the current is changing, I know by experience that my operational window shrinks. But then you have also the mechanical side, which is how do we design a system to allow more degrees of freedom or a faster way to retrieve whatever needs to be retrieved so that we can operate in harsher conditions. So it's always a mix between hardware and software of how do you design a system which doesn't become extremely heavy and expensive for just 0.5% of the cases, but allows you to increase the complexity of the environment we work with. If you can only work with flat seas, then you work 10 days a year. That's bad. But if you can work with 2, 3 meters, suddenly you increase that. So that's how I like to look at it. What can we do to play with our window without going into some crazy assumptions that we need to withstand the biggest storm?
Okay. It's really interesting. I guess, for someone who sits in this world day to day, it's really, really interesting where a lot of the conversations I have are more these environments of, okay, well, it's just we need to add another arm to it. It needs some higher degrees of freedom. Oh, okay, let's focus on like the manipulation or like vision
Yeah,
stack more so than kind of really putting all of those smaller pieces together with this. Hold on, can it actually now operate if the storm goes up or the water goes above this height or the waves are above this? It's a really interesting and different way to kind of think about operations in these types of environments.
yeah.
Um,
And just before we go on, I told you what I like is systems, right? So here, what we see is if you engineer out the best mechanical arm on the planet, but you do not know what a smart arm could do, then you may end up with the best mechanical arm on the planet, which actually is very, very expensive. And same as if I have an AGI driving my boats, most likely it's going to be awesome, but how much does it cost? And that's where, when we think of systems, robots, we cannot do one without the other. And that's really where I would say our job as robots leaders or whatever is to make sure we find that balance. Because at the end of the day, we don't have unlimited resources. We don't have unlimited time. We need to solve a problem, and we have infinite ways to look at it. So I like that to be a shared burden between the hardware and the software. I don't think that it should be in isolation completely. It shouldn't also be 100% overlap. But when we think about robot, it's really the way where we link the physical world and the software world. And a very smart brain may be able to move a very damaged body in a nice way, but if you have the best body, maybe you don't need to be that smart.
Very true. Maybe interesting analogy. I might take that from you one day. And I mean, for me, like hear a lot of people speaking about this full autonomy, this zero teleoperation, this, brain is going to be implemented so it can do everything, like no human involvement. And look, you have one arm where you've got, humanoids being argued in homes, and you've got the others going, no, actually, we need that kind of teleopside to remain, of course, at a lower volume for higher output, but still. Yeah, this hype in like full autonomy and the what is should be fully autonomous and what kind of shouldn't is a big ongoing discussion. I know we've touched on it before, but in like maritime and marine systems and things that operate in like super unstructured environments, or you're talking about drift currents where like think the environment itself is ever changing. Like how realistic is full autonomy, or like what is like the sweet spot in like kind of marine robotics? Is it like autonomy? Is that even the right word? Would you define it and categorize it as something else entirely?
Well, quite frankly, if you have infinite money, you can do whatever you want. But the reality is that we need to solve a problem for businesses. And each business has a different problem to solve, so that means that you don't always have the same solution. Full autonomy, it's something I don't use often. I only use it in when I have a drink somewhere and just that it looks fancy, I'm working in autonomy. But in reality, if you look behind the hype, right, the buzzwords, autonomy is really a mean for an organism, whichever it is, to survive in an unknown environment entirely. Do we want our robots to be that complex? I don't think so. Um, we may want the thing to become what I like to refer as, and I forgot the way I like to refer it as. It's scenario-based automation, right? Basically, you want to be able to have a subset of behavior depending on where you are. And if you know the business and the work you have to do, you should be able to somewhat clearly give boundaries to where you send your robots, right? So let's say currently in my job, we send robots from shore to a place where they deploy an ROV, they do some work, get the ROV back, come back home. So you have phases. Leaving port may be an insanely complicated job because we have big vessels, because we go offshore and they need to be robust. So you have the inertia of moving the boat, you have all the things around you, and you also have humans nearby with a remote controller, with ways to go on the boat if things go wrong, in any case. So I may actually not care much about any automation here. But if I go on transit and I need 1, 2, 3 days to go to site, then suddenly it becomes a very boring cruise where you just watch screens with gray sky, gray sea, or blue sea if you are lucky enough. But then what's the point of having full-time supervision watching screens? That's where you may want to have more automation. And the automation may very well be, I see something, I send an alarm. That's already much better than doing nothing, you see? And when we are close to the place where we work, the automation may be automatically launch the systems, get them back. It can be, hey, I know that for the mission you need to go in cycle for 10 hours, so you can automate that. And so when you take them all side by side and you put them into a nice orchestrated mission, it looks like autonomy because it also knows how to react to the things which only happen in that phase. But it's not autonomy. You see, when you are in transit, you may encounter container ships. You may not have suddenly a big structure sitting next to you under a storm. So you don't even need to cater for those things which don't happen. So that makes the work much more digestible, much easier to segment and to develop. And also, if you look at your whole production pipeline as a company, you know where you make money and you know where you waste money. So you can look into how do I make my missions better, more efficient? How do I reduce the waste that we do during any type of mission? And how do I make the job that I'm currently doing maybe more efficient? So it all goes back to a very boring production management issue.
Fair enough. And I think it's interesting where like you kind of, rephrase it yourself as, it's not autonomy, it's scenario-based automation. And please correct me if I'm wrong. My brain takes me to this is, that is that task-based or automation where like you need it to do A, B, and C alone or like in its own free rate, but outside of that everything is still that kind of human interaction factor. And so you kind of mentioned like remote supervision, teleoperation, so of course
Mm.
you've got like the safety aspect and maybe some of like the data aspect where you still need some of the supervision where it's not all like autonomously collated and whatever. But we kind of, I appreciate in this kind of industry we see remote supervision as something that's not, they're not trying to remove it. It's not like a failure situation that someone needs to sit there and watch it. It's a design choice, right? And is that is that more because it's just such an unstructured, unknown environment, or is it because there isn't a way for this to be done in a autonomous, whatever you want to phrase it as, way?
No, so you always can find ways to make it happen depending on your business case, right? And I'm not saying that autonomy is not the way. Some companies may want to go much more, how do you say that? They may want to give more freedom to their robots depending on what they have to do. It's just that you have to work on more edge cases if that's where you want to go. Fine. When I looked at what we do, I looked at the strength of our company. I looked at where we have our value. And instead of trying to replace that, remove that, I tried to basically lean on that to make it easier to operate. So you keep the core business, which is in our case, having competent operators do a job and do it well. And instead of trying to say, well, I can do it better, you start to say, hey, maybe there are lots of things that waste your time. Okay, so we removed some of the pilots from the shore to onshore because of safety and efficiency reasons. We should be able to send out more robots to do those type of difficult jobs. So what can we do with software automation and robotics to ensure that the added value remains where it currently is? Um, and actually, that's kind of a nice way to look at this because um, I've seen all sorts of scenarios, going for full autonomy, maybe without a business case in some cases, or going for, well, actually, I'm going to go very, very slowly. Um, but what's important to understand is that software, there is no limit to where you can go, what you can do. So if you think back as business management, product management, where is the added value? How can you deploy, already generate savings revenue with what you do? How can you build the technology which is being used as soon as possible so that you can learn, ruggedize, industrialize that, eventually derive some other business models from that? And it's just being very pragmatic about what we do. Yes, honestly, it's cool. I'm super happy when my autonomy team comes up with detecting dolphins in the ocean. Um, but at the end of the day, why do we do that? Because there is a
Mm.
business need, because we know that by doing so, we help our operations and our production pipelines to be more efficient. And I guess that's the same with production factory robots. It's just that my factory is open air. We don't have walls, and that's just a bit of a different problem.
Okay, that's very interesting. I think, from this conversation or anything kind of previous, I think it's kind of fair to almost say that this is probably one of like the harshest kind of deployment environment to really have embedded yourself in throughout your career, right?
Well, I would be cautious and say I do not know. I think it's hard enough. All environments have their difficulties. Of course, we have motions, we have so many things. We are, also the ocean world. Um, not everything is automated. We don't always have the nice sensors which are made to be going subsea 600 or 6,000 meters. What you find on land, the industry has hundreds of thousands of robots. If you look at flying drones, it's insane. It's extremely mature, extremely miniaturized. In my field, we have tens of units for offshore USVs. Onshore is a bit more. Nearshore is a bit more. But subsea robots, autonomous vessels, tens, maybe a couple of hundreds worldwide. And they are all very different because they have been built by people who need to improve their work. So you don't have standardization. Not everything is automatable easily. Not all the layers for orchestration of the hardware on board with the autopilots, not all of that is still very early, right? It's still very in its in infancy because yes, the technology exists, yes, the logic exists, um, but the industry is in a phase of maturing. So you will find that developing technology for the ocean usually ends up being more difficult and more costly because you do not have 1,000 toys to play with. You do not have 100,000 users sending you data from your flying drone. So you have to be very intentional about what you prioritize, what you start with. Again, I do not know about space. I'm fairly sure they do not have thousands of toys to play with either. And for the car industry, they have a lot of assets, but they also spent a lot of money. So there goes that.
Yeah.
Um,
And that was a hype we were meant to all be like in self-driving cars across the globe by now. So yeah, we're definitely a bit
yes.
far behind then. I think where you kind of mentioned the drone piece and having so many toys to play with, it brings like a bit of a fun question from me actually. I've seen quite a lot of these kind of like swarm teams build out where, they put a little backpack on a fly and they send it out to collect data. What's stopping you from putting a little backpack on fish and just being like, go collect some data to me and like to treat it like a returning pigeon, be like, come back to this spot. Like, could you do that? Would you do that? Is it worth doing
Um,
that for anything? Like, I know this is so off topic, but it's got me thinking now.
I haven't trained fish to do anything useful for me. Um, but that's a good question. Yes, we need to have more data, right? And what you find is that many people do. Many companies try to actually understand what's happening at sea. There's a lot of data from major suppliers of automation systems. Most of the boats have some sort of automation, so you have that. It's mostly addressed to larger types of vessels, 50, 100 plus meters. So we are in that weird zone where we are not doing small crafts anymore, but we are also not doing large container ships. So we need to fit in all sorts of IoT data in things which don't really exist. So how do we get that? We need to have a large network and be able to have lots of friends who actually are happy to allow us to put systems on board of the vessel or robots so that we can collect things. And even then, it's still a very small subset of information. But what my teams have told me, because now I've become quite obsolete in the AI field very quickly, actually, we can do much more now with the new models than we could a couple of years ago already. We need way less data to train our systems. We can also start to link all sorts of LLMs with vision, with all sorts of things so that it becomes much faster, so that we have more flexibility. So I would say when a couple of years ago it required a heavy logistic to get to that, well, just basically those numbers. Now there are ways which are a bit smarter and leaner, which we are looking into and exploring, and which may help us go into other types of use cases without having to collect too much experience on that.
Okay, really interesting. I think, with the whole data is king kind of thing that everyone runs at, and like, of course, data is king. Like, how
Mhm.
can you work out what to do next if you haven't mapped out the environment or the understanding? So I think it's a really interesting point you make, and it's really nice to hear it from kind of your perspective. And I think with that, I followed on into like there's obviously some really interesting differences, but also things that people can learn from across different disciplines, whether we're talking, land robots, logistics, robots, humanoids, you kind of name it. So like, are there any, I guess, apart from safety, because that will probably come into everything, what lessons would you like if you were to sit in front of a panel right now of a humanoid robotic leader, someone who has spent 30 years in AGVs, someone who works with an industrial arm and cobots? Is there like a core lesson that you would say that you've taken from maritime systems that you could transfer across the rest of a robotics discipline?
Yes, I think there's a lot of commonalities. So it's both a blessing and a curse. You will often hear people ask, hey, why don't you use a DJI autopilot on your boat? Fair question, it's an autopilot, right? Um, and the answer is a bit more complicated because the domain knowledge is different. So what you find out is the philosophy to make robots is almost always the same. The way I like to represent that is if you want to make a smart robot, it needs to have, same as we do, ways to perceive your environment. So we have eyes and ears, ways to communicate with antennas while we have mouths, hands. They need ways to contain their physical shape, which is our body, and ways to interact with the world, which is legs for the thrusters and propellers, and arms and hands for whatever you need. So all of that is true for almost all robots. You just take more or less of that thing, and all animals, right? So the thing is, the philosophy of how you build a robot is the same, both in terms of the hardware. So basically, you need to be able to interact with your environment, and how you start to build the way the brain is composed. So the way a robot senses its environment is through sensors, but as I said, at some point you have to understand that you have detected things, and then you need to be able to put them in space, and then you need to be able to understand what they are or not, to be able to have a reaction to it. Um, I really love to cite my beloved vacuum cleaner because it does just that. It has a LiDAR which maps my walls and probably sends that data somewhere. I don't know where. Um, it, it maps my living space. It has cameras to detect what's on the floor, and based on that information, it knows where it is, it knows what to avoid, and it cleans relatively well because it has wheels to move and it has brushes to do the work. It's all the same. Communicates with my phone, with the antennas, and it also speaks when it doesn't have water, and it's very annoying. So that's the same. What differs fundamentally is the domain knowledge, right? So you may very well go from one to the other if you just are curious enough to understand, okay, which variables are changing for you. If I work for mining robots, well, do they have connectivity? Do they have a network of connections in the mines? How do they recreate 3D worlds around them? Is it done? Is it easy? How do they move? How smooth is the environment? How dangerous it is? And and yeah, so you can go from one to the other as long as you are curious about the work to be done, as long as you understand the constraints. But there's a lot of commonalities, yes.
Okay, so you've really just put it down to mainly like that domain knowledge and the specific problem that needs to be solved, really.
Yeah, it's fair question to ask why don't we use a DJI autopilot everywhere, but it's also a fair thing to try to understand why it is different and why it may or may not work.
No, I love that. And it's really interesting again to think about it from a different physical environment domain where a lot of people, I'm sure, maybe, not everyone, but a lot of people are used to this more structured environment, whether it's a GPS a, a green environment like cars on road or anything from low connectivity warehouses to satellites to subsea. So it's really nice to think about it in a different kind of form factor as well. um and I mean, Jonathan, for me, this is the type of chat I kind of love, where I feel like I've learned a lot in it. Hopefully, I've asked you questions that haven't led to just political answers, but I think it's a really nice way to speak about the industry and ecosystem in a different way, where autonomy or scenario based automation is defined differently or kind of treated as success being different. It's not, can this thing do what it's meant to do without any interaction? It's how can we make it the best for our outcomes, our partners, our customers, irrelevant of the 100% autonomy, because that's not, your direction, which is really interesting when everyone's going, 100% autonomy or nothing in humanoids. And it's, yeah, a nice way to hear a different vein for it, I think.
Oh
And,
yeah,
oh, sorry.
I absolutely, I no, I was going to say I absolutely love that. When we talk about success, success with no constraints is just playing life on easy mode. I think that if you have constraints, then you have a benchmark. You have an environment to basically know, am I being the best? Am I doing the best here for that type of problem? And so it's both very creative and also a bit competitive. So I like that quite a lot.
No, really appreciate that as well. Like, it's really nice to have your way of thinking on this type of podcast. And before I let you go and before I kind of wrap up on this, is there anything for you, Jonathan, that I haven't kind of touched on today in your maritime systems world, or that you think people working in not just, subsea or marine robotics, but the robotics ecosystem as a whole, that they should really understand about deploying systems in these very kind of unstructured or low communication environments? Yeah, is there anything I've missed that I should have thrown at you today?
You asked a lot of very good questions. I couldn't answer very precisely to all of them, but I would say what's really, really important is to stay curious about the things you do, learn from the people who have done the job that you try to help them do before. Honestly, it was the same with lean manufacturing. You go and you talk to the operators, you understand how they work, try to support that, try to help them. And don't be afraid to ask stupid questions to break the status quo because sometimes, we are also human beings. We come with preconceived ideas of why we do the things we do. So in the offshore world, what surprised me and amazed me is how dedicated the people are. They are really proud of the things they do. They have been doing a great job in very harsh conditions. So I really love to see how they embrace new tools. What I've seen is that you may expect people to be hostile to that change, but absolutely not. I see a lot of embracing the change, challenging us to design solutions which actually make sense, challenging us to do something which actually helps them do the job better, and take ownership of that technology and do the work the best way they can. There's a lot to learn, a lot to do again. The road is still long. And yeah, for me, what's really important is to stay curious and yeah, do your best.
I love that. Um, well, I think then for me, I'll leave this as I mean, look, whether our listeners are dealing with this constant level of uncertainty or are building robotic systems that operate in an arena where, everyone else, everything else stops working, whether it's the communication layer, the perception layer, the network, offshore robots, marine technology, maritime robots, whether you're talking ROVs, USVs, it feels like one of these like ultimate like stress test for the entire robotics field in terms of like how it operates and how differently I think you guys think about autonomy or what should be defined as successful in automation these projects. So for me, this has been a really, really cool lesson. I think anyone who's either stepping into this space or is looking at offshore robotics and offshore applications as a new venture away from something maybe more standard ground robots that we kind of hear more of. I think it will be a really interesting listen. So from me, all I can say, Jonathan, is thank you so much for like coming on the show and being a guest on one of our episodes. It's been a super insightful chat for me. So I hope it's been really, really interesting for all of our listeners too.
I hope so too. Thank you for having me and asking all those nice questions.
A real pleasure. We'll have a lovely afternoon, Jonathan, and thanks for coming on.
You too. Thank you.